Good afternoon. Recording in progress.
Good afternoon, everyone. We're now at the parallel session for biosecurity and biosafety. Our first speaker this afternoon is Dr. Rahani C. Navarro. Dr. Navarro is a veterinarian and assistant professor at the National Institute of Molecular Biology and Biotechnology. She's also the assistant director for the National Training Center at the same university. She earned her Doctor of Veterinary Medicine from the University of the Philippines, Los Baños in 2010, an MS degree at Chonnam National University in South Korea. Dr. Navarro is also the chair of the UP Manila Institutional Biosafety and Biosecurity Committee. She received her certification as a biosafety officer under the Philippine Advanced Biorisk Officers Training in 2015 and is also a certified professional by the International Federation of Biosafety Associations. As an advocate of biosafety, she led several capacity building projects in promoting biosafety and biosecurity awareness in the Philippines. Ladies and gentlemen, let us welcome on the virtual screen our very first speaker, Dr. Navarro. Excuse me, tech team, there's no sound.
Today, I'll be discussing the efforts of NTCBB, our institute, in understanding the biosafety and biosecurity landscape in the Philippines towards the development of the National Biosafety Framework. Just to give you a brief background of our center, it's a 13th institute of NIH in UP Manila and was launched in February 22, 2018. Our goal is to create a national center for training and practice, which advocates for biosafety and biosecurity among research, academic, and healthcare institutions in the Philippines and the Asia Pacific region, and to promote the culture of safety and security in all laboratories in the Philippines. Our major function is advocacy and leadership, training and awareness program, contribute in the development of applicable biosafety standards and generation of best practices and standards in laboratory safety and security, as well as create mechanisms for both degree and non-degree programs that will enhance the professional practice of biosafety and biosecurity in the Philippines. One of our flagship programs is the Advanced Biorisk Officers Training, which has generated over 102 biosafety officers in key institutions in the Philippines. The program is actually now on its 6th certification program. We also provide biosafety and biosecurity to different institutions as well as international fellowship program. The Philippine Advanced Biorisk Officers Program, or ABOT, is a comprehensive 6 to 8 in-person training. It's one of its kind and it includes competitive selection of applicants. The students are trained for 6 to 8 weeks, which includes lectures, didactics, and hands-on activities. A certificate of completion is awarded for successful students who completed the training and passed the final exam. After the training program, the biosafety officers return to their home institution and are expected to create programs or at least establish their own institutional biosafety committee in their institution to serve as an oversight for biorisk management activities in their agency. We take pride of our biosafety officers who have created their own programs in their institution and even offer their expertise to other laboratories or healthcare facilities. We believe that there is strength in number, even if we only have a few graduates, but we saw the significant role of our biosafety officers, especially during the pandemic. During the onset of the pandemic, the biosafety officers or the graduates of the Abbott program gathered together to create an online biosafety education and awareness training, or BEAT program, which was offered to all laboratorians or healthcare facilities who are planning to set up their COVID-19 facilities. And the officers came together and developed the different modules and offered their time and volunteered for this significant training that helped the Department of Health in terms of provision of training to our laboratorians. In effect, We have trained more than 3,000 laboratorians from various institutions, various medical professions, and even resulted to about more than 100 DOH accredited COVID 19 testing laboratories by the end of 2020. Now, in the next couple of slides, I'll be sharing the efforts of the center together with its partners in the development of the biosafety and biosecurity framework to better understand the landscape here in the Philippines, what's already there, what are the gaps, what is needed, and what are the things that we need to do moving forward. This effort was initiated back in 2018 when we're starting to propose for the creation of the center. And the results that I'll be presenting later, I believe, are still relevant given that even during the pandemic, we saw how important biosafety and biosecurity is in terms of dealing of an unknown pathogen. Now, this effort was made possible through the efforts of our partners, specifically the Institute of Health Policy and Development Studies, National Institutes of Health, UP Manila, and our partners from the Defense Threat Reduction Agency, Black and Veatch Silor, and NDEC Incorporated. So during the development of the framework, we did a rapid policy analysis, a consultative conference where we bring together the stakeholders, engagement with policy making bodies, which we are still doing up to today, and drafted some legal instruments as needed. So we started the policy analysis by retrieving the documents, the relevant documents that's related to biosafety and biosecurity, the laws and policies database, as well as website search. We retrieve a couple of documents, around 22 admin order, Republic Acts, guidelines, department circulars, executive orders, manual, and a UN resolution. The entities covered, we've tried to categorize them as the like animal sector, plant science or entomology, biotechnology, and laboratories and security. But what we found out is there a gap, especially on the security and how it can be bridged together with other entities that were covered. So there's really a lack of an overarching framework that can adequately handle these processes and products. Now, in 2011, Dr. Robert Heckert, also one of our mentors in the biosafety and biosecurity, published a paper on the 9 categories for developing a sustainable capacity in biosecurity and biosafety in LMIC or low middle income countries. He and his team identified these categories such as the regulatory framework, the availability of equipment, reagent, and services, building the capacity through training, biosafety awareness, operational management and processes and admin control, biosafety associations and professional competency and credentialing, infrastructure, biosafety curricula, and individual mentoring or organizational twinning. Now, in the next couple of slides, I'll be presenting on the results based on these 9 categories. So, in our initial analysis, based on the regulatory frameworks or the guidelines, we have identified around 17 entities that are guided by a framework or follow standards. These framework or standards are determined by the government agency, a committee, or these agencies follow certain international guidelines. So this is more than half of the entities that were retrieved during the policy analysis. Only 3 out of the 27 entities identified are provided with biosafety awareness guidelines, policies, measures, guidelines on disease outbreaks. And few entities, certain few entities follow certain infrastructure guidelines, but the level of detail varies between these entities. So it means that only few entities actually follow, for example, certain guidelines, specifically, say, for example, related to biosafety and biosecurity standards. On the equipment, reagents, and services, a few of them are guided with the guidelines for provision of equipment, reagents, and services. There are guidelines, say for example, that includes the minimum requirement for a certain facility to operate their laboratories or hospitals. 20 entities are provided with governance mechanisms in terms of management processes and administrative controls. And these guidelines are created through, for example, issuances, or these guidelines are communicated through the issuances of, let's say, for example, memorandums, administrative orders for these guidelines to be implemented. During the time of policy analysis, there was no biosafety curriculum that was identified. From the entities identified, 8 follow training guidelines, which includes capacity building, but probably some of the entities do not have, say for example, a specific training plan that helped informs, say for example, a professional on what kind of training or competency does this professional need, say for example, in a certain institution. There were no mandates in the Biosafety Association's professional competencies and even credentialing, and there were also no mandates in terms of the individual mentoring and organizational twinning. We did the consultative conference in 2018, which were attended by the Abbott graduates as well as the different stakeholders, and it was also coincided with the NTCBB launch. So during the consultative conference, the participants were asked to identify who are the stakeholders or who are the key agencies that will contribute in terms of the overarching development of the biosafety framework. And the identified agencies were categorized based on, say, for example, professionals and facilities, agencies that are related to or has a mandate on accreditation, law enforcement, transport, and funding and investment. But what we found is that there's still a gap in terms of the overall coordinated response to an event, or let's say for example a pandemic, and that was identified as a gap to have that an overarching document or a guideline that will encompass that handles all these identified roles and responsibilities. The participants were also asked to prioritize, what's needed for the country. And what we found is that there is a need to build the capacity of the existing facilities for them to comply with the proposed policies and standards. There is a need to professionalize the biosafety officers or even create a permanent position for them, since right now the practice is that the biosafety officers are doing their job on top of their role, no? And then what's also needed, or what was identified, is to enhance the quality and outputs of the laboratory. So those were the prioritized priorities that were identified during the consultative conference. So during the consultative conference, what we learned is that there is really a need for a crosstalk between agencies, that these agencies really need to work together to have a coordinated response. And there should be a consistent and coherent policies that enforces the biosafety, biosecurity, and biorisk management. There is a need for the regulation of facilities, especially in terms of handling pathogens and what implications it has in terms of biosecurity. There is a need for the inclusion of funding for the related activities into the national budget, and the need for the engagement of stakeholders, because this effort it cannot be done by one agency alone. So obviously there's still a lot of work that needs to be done, and it's not a unique problem to the Philippines. I believe other countries, I believe, also face similar challenges in terms of creating that biosafety framework that's tailor fit to their needs. And I just think that we need to start somewhere, and we need to start now, because for the next pandemic, I think that it's only a matter of time, no, for the next pandemic to happen. So these are our references, and again, I'd like to thank our partners who worked tremendously in the development of the biosafety framework, as well as our training partners. And if you have any questions about the programs of NTCBB, I'm sharing the contact details of the center. With that, thank you very much for listening.
Thank you so much, Dr. Navarro, for sharing your team's advocacies with us. Before we proceed to the next talk, let me just remind everyone to please key in your question in the chat box. We will have an open forum after three speakers. Our next speaker is Dr. Supachai Nunusuan, who is the head of the Center of Excellence for Food and Water Risk Analysis, Department of Veterinary Public Health, Faculty of Veterinary Science, Chulalongkorn University in Bangkok, Thailand. His research interests are risk assessment and risk management of pathogens. Dr. Nunusuan, the screen is yours.
Hello, everyone. My name is Supachai Nununsuwan. I'm very honored to be invited to be the speaker in this meeting. And I'm from Thailand. I'm the head of the Center of Excellence of Food and Water Risk Analysis from Faculty of Veterinary Science at Chulalongkorn University. And today I would like to present part of my research project. And this project is an ongoing project. And hopefully, if possible, I will be able to share with you the result. However, today I would like to talk about the biosecurity of the swine farm, particularly after a emerging disease in of the swine farm from African swine fever virus. And I think it's time to share my slide presentation. Okay, hopefully you can see it, the slide presentation clearly. And okay, the topic under the theme of the biosecurity is ASF risk-based biosecurity for restocking, risk assessment of Thai swine farms. Again, I'm Supachai Nunusuwan, Center of Excellence of Food and Water Risk Analysis, or FORA, from Faculty of Veterinary Science, Chulalongkorn University from Thailand. And okay, since those who might not be familiar with this disease or virus, since this actually is the disease in the pig or the swine. So most of you that focus on only the disease of human or public health aspect might not be familiar with this. So I give you some of the background and significance why we are, I mean, in Thailand, in our project, we are interested in this. The etiology or the cause of the disease is so-called African swine fever virus, or in short, we call it ASFV. And definitely from the name implied is virus caused the African swine fever. And previously, this I mean, even now, some of the farm has been susceptible to this virus and cause the very high risk of morbidity and mortality. And since this is the disease caused by virus, so for now, still there is no cure. And however, the vaccine is still ongoing and expect to launch soon, since we have many countries and many collaboration all worldwide in order to get the effective vaccine. In Thailand, it has been officially occurrence, I mean, officially report earlier this year since January. Okay, and the consequence is huge because of the economic impact nationwide. And so some of the swine farm decided to do the total population, because total depopulation, because it has been affected almost all the farms, since maybe part of it because of the biosecurity, or I mean the depending on the level of biosecurity, and especially for the small holder farm has been affected a lot. However, the medium size or a more integrated farm probably has been affected partially, so they will might go for the partial depopulation. However, no matter degree of the depopulation, once we know this virus, and then we might do something, right? And that thing could particularly will be the biosecurity, and in order to restock and come back to to do the business again. And in this project, we adopt a control measure or control approach. We using the import risk analysis, and this one has been recommended by OIE. What is OIE? OIE is the International Animal Health Organization, and this organization has recommend also some the procedure in order to keep the health of animal in a good shape. Okay, next. As I mentioned in the earlier slides about the import risk analysis, this is, as I told you, this has been adopted and recommended by OIE. It's composed of the very first step is so-called hazard identification. The hazard particularly is the pathogen that caused the disease in a certain country. And then the next three components are the risk management, risk assessment, and risk communication. And as I mentioned in the title of this talk, we will focus on the biosecurity, and biosecurity basically is the part of the risk management. And since we could not rely on only the risk management option or biosecurity measure in because there are so many things in order to implement the biosecurity. So the idea of this project is to endorse or bring about the risk assessment in order to evaluate, in order to understand the loophole or the problematic topics under the biosecurity, in order to improve or finally to successfully or sustainable restock of the soy farm. And for the risk communication in the third component here in this cycle is about the communication between the risk assessor and risk manager. And in our project, we adopt the idea of risk communication to like communicate between the lab result and the swine farm, because we would like to sort of monitor what's going on in the farm, because we cannot see the virus. So in order to know that, to know whether there is in order to whether to know where the virus is coming into the farm or not, so we have to rely on the lab result. Okay, and among the biosecurity, we were thinking about biosecurity of the restocking. We were thinking about the review step is to check whether what's on hand in our farm, what is the loophole, and then if we can identify it, then we renovate it, make it better. And after that, we hope to get to restock the pig into the farm. For the risk assessment under the recommendation of OIE, there are 4 steps. The first step is entry assessment, second step, exposure assessment, followed by consequence assessment. And to wrap up the first 3 steps, we get the risk estimation. In fact, import risk assessment has been adopted in a country level. As you can see, this is the map of Thailand. Okay, and we have 3 colors like red, white, and blue. And in the first step, it's so-called entry assessment. This step basically is to evaluate the chance or the probability that the hazard, as we mentioned in this case, is African swine fever virus or ASV, whether what is the probability that the virus can enter or move into our country. And once it set foot in our country, then the next step is exposure assessment. As the name implies, is where the virus or ASFV meets the host. In our case, is the pig, the live pig. And the next step is the impact, or what's happened after the pig exposed to the hazards, is so-called consequent assessment. And in this case, it's just like epidemic or outbreak that happened previously. Okay. We can also apply the import risk assessment from the country level to the farm level as well. We have an entry assessment, we have the virus and exposure assessment, whether the SFV will meet with the host, which is our pig, and what happened is the pig get the fever and it gets sick and finally die. That is the conclude of the 3 steps. We get the risk estimation. Because the time is running, we are running out of the time. So we basically do 2 things, and I would like to emphasize that we do the risk assessment and risk management. The biosecurity is under the risk management. However, again, as I mentioned earlier, in order to evaluate the successful or effectiveness of biosecurity, then we have to rely on also the laboratory testing as well. However, basically, we start with the farm, then we consider the small farm and medium farm. The definition of the small farm is less than 500 pigs, okay, and medium size is less than 5,000. And we categorize the pig by the biosecurity scale. We have low, medium, and high. As you can see, we have the low, moderate, and high. We expect that the group in a low biosecurity will be the small with the open structure. It means in terms of biosecurity, moving in out is a little bit looser. I mean, not very strict in that sense. Okay, and we also create or bring about a prototype of the SF risk-based biosecurity. Why we say risk-based? Because we will adopt the idea of the risk assessment. As I mentioned earlier, we have entry assessment, exposure assessment, consequence assessment, and risk estimation, and matching with the biosecurity. So we make it as a ASF biosecurity. And we also adopt some of the result from our earlier project, which has been done probably 1 or 2 years ago. We have the idea of the inactivation. We use the physical inactivation, chemical inactivation. Essentially, we use the disinfectant and to see how the virus persists in the environment, in the manure, in the slurry, and biosecurity assessment. Also, in order to generate or bring about the prototype, we rely on the GFM or Good Farming Manual from the DLD in Thailand and GAP or Good Agricultural Practice. And again, time is running out. So as you can see, that under the biosecurity assessment, we need to do the biosecurity checklist. Okay, and again, this is based on risk-based or ASF to check whether in what aspect that the virus can gain entry into the form, and with the checklist we matching with the sampling, and we have the 4-step sampling, and then to verify or to check whether the risk base is working or not. So this sampling should be do the lab validation. This is the link between risk management and risk assessment. Okay. Under the biosecurity topic, we have the SWI. I mean the source or the way or the pathway that the virus can get into the farm is either from SWI, from staff, feed and water, or from mite, or in the surface or in the environment, and we matching with the 4 steps of the risk assessment. And I think the time is running out of. So we're trying to use the cross-sectional study and verify with the odds ratio. The odds ratio is to correlate the biosecurity topics, as I mentioned, like staff, SWI, formite, and feed and water with the lab detection. And if the odds ratio is more than 1, so it means that the disease is associated with the factor. But in our case, we think of biosecurity as a preventive measure. So we expect the odds ratio to be less than 1. And for example, this is for the mock-up idea. For the biosecurity, we have the F stand for the factor or the biosecurity, and the lab detection. We have this is positive or negative. I mean, the positive of the virus, and then we calculate the odds ratio as I show you here, and then it gets less than 1. So if so, then it means that this biosecurity topic leads to lower lab detection, or lead to, I mean, it means that biosecurity can prevent the virus from getting in. Okay, so the conclusion for this talk is we try to correlate the risk assessment and to verify or to evaluate whether the biosecurity measure is actually working or not by determining the odds ratio. Okay, so thank you very much for being interested in my talk. Okay, thank you. Bye.
Thank you also, Dr. Nuno-san. Our third speaker for this afternoon is Associate Professor Dr. Masato Saito, who obtained his PhD degree from the Graduate School of Material Science at the Japan Advanced Institute of Science and Technology in 2004. His research interests include the micro-TAS biodevices, rapid PCR detection chip, plasmonic biosensor by nanoimprinting technology, and single immune cell analytical device. Since 2008, he has been affiliated with the Graduate School of Engineering at the Osaka University. And since 2022, he has been a special appointed associate professor in Life and Medical Photonics Division, Institute for Open and Transdisciplinary Research Initiatives at the same university. It's all welcome, Dr. Saito.
So, Professor Fujiyama, I'd like to say thank you for giving me this precious opportunity today. So I would like to introduce my two research topics. One is the development of easy and rapid PCR for pathogen. Another, if I have time, so I would like to talk about the trial of development of automatic detection system for chemical and biological agents using electrochemical and photonic biosensor. So now let's go to move about PCR device. Initially, I want to touch about our motivation as background in the various fields. So we are always facing so many trouble caused by the pathogen. In this situation, if the pathogen could be identified, it will decide management policy speedy and can prevent expansion of damage. However, so PCR also had a big question about the rapidity and its handling. So in any field, it is impossible to do this pressure handling by untrained user, and also it has difficulty to wait for over 1 hour. So to overcome this issue, the first reaction time for the PCR should be shortcut to the limit. Secondly, liquid preparation step should be removed. And then if these two steps would overcome, so finally it should be integrated in one system. Here, to realize these key points, we focused on the thermal convection. This equation shows the linear convection, and this equation has the gravity-dependent term. If the gravity could be controlled, thermal convection velocity could be controlled. There, I had made an idea. So if the field of force placed to horizontal direction, it means the force applied to the solution has a relative gravitational acceleration by centrifuges instead of the gravity. So this is the schematic illustration for relation of the microchannel and the heat source. So ring structures microchannel placed onto the two heat source. So these two heater makes temperature difference in solution of microchannel. So these sets rotate with heating. Then thermal convection was generated in the microchannel, applying the centrifugal force, and its velocity also controlled by regulating of rotation speed. To confirm this idea, I fabricated its experimental model. This is microchannel jet for centrifugal thermal convection PCR. Microchannel had a ring structure and depth was 300 micrometer and width was 500 micrometer. Material was just the cycloolefin polymer, COP. COP is suitable for biosensing, so because of that, the heat resistivity and liquid resistivity, and has very low photoresistance. Microchannel placed on the heater, so like this. So this is a high temperature heater, and this is a low temperature heater. the solution make the temperature difference in the microchannel. Thermal convection really generate or not. So we observe by using the assembled device and high-speed camera. But during centrifugation, high-speed camera synchronized with one shot at one rotation. This movie showed the actual thermal convection. So white sheet was placed between chip and heater because so they can be seen easily. Actually, heaters were placed under the white sheet. So initial solution contained a new coxine dye, so for after visibility. So you can see the thermal convection was clearly generated, but the convection speed was slow. Only, however, so you can see that the convection speed was increased with increment of rotation speed. So we could confirm that the thermal convection can be generated and that speed can be controlled depending on the rotation speed. We also done the simulation analysis, but sorry, so I would like to skip for time. Now, as you know, the studying and caring for the drug resistance bacteria is promoting as a worldwide issue. So now, medical doctors strongly required to ask the development of the rapid gene detection system. So then I had to try to apply the detection of drug resistance gene. IMP6 is one of carbapenemers and was picked up as a target for the rapid on-chip DNA amplification. So rotation speed, reaction time, and so many conditions was optimized. And so IMP6 was successfully detected from 200 picogram E. coli dynamic DNA. We also estimated the applicability to clinical sample. So this was supported by the former Professor Tomono and his group in Department of Infection Control, Osaka University Hospital. Totally 178 clinical samples applied to on-chip PCR. So swabbed human stool sample was suspended in solution and boiled for 5 minutes. Then the sample was mixed with the PCR solution directly and applied to the chip PCR. The result was compared with plate culture as a standard method. So chip PCR showed a good accordance of 86% with the culture result. So thus, some results show the little bit so disagreement. So in case of plate culture was negative and chip PCR was positive. So this case is the bacterium was died in the stomach, but so DNA was remained in the stool and then DNA was detected. In the case of the plate culture was positive and the PCR was negative, so this was a little bit so different. This was so that the drug resistance had another metabolic pathway which is not depending on the carbapenemers. So then, so PCR couldn't detect the carbapenem the DNA. So anyway, our device was applicable for the rapid DNA detection almost directly from the human stool sample. So next. So we are currently aiming to establish a startup based on my technology. So prototype have been developed already. So here I would like to introduce by the movie a little. But so sorry, the narration is in Japanese, but so there is subtitles in English.
検体採取キットがセットされると、検体と試薬の混合液が毛細管現象によりチップ内に刻まれたマイクロ流路に沿って放射状に流れます。さらに混合液はマイクロ流路に沿って流れ、チップ内の小部屋を満たします。マイクロオーシャンではチップを高速回転させるという大きな特徴があります。チップが高速回転すると、小部屋を満たしていた混合液が遠心力により円環状のマイクロ流路に注がれます。この円環状のマイクロ流路にはあらかじめプライマーなどがセットされており、必要な試薬がすべて自動で混ざります。
We are trying to apply the detection of coronavirus and visualization of the gut microbiome by using our prototype device. So we also made the saliva sampling too, and from the studying the saliva sampling, so we could successfully detect the corona at 13 minutes from the human saliva. So recently, gut microbiome is attractive for health. So now it was possible to measure the ratio of the model bacteria for each person and to see the improvements of bacteria ratio by intake of yogurt and dietary fiber. We are trying to construct the support system for healthcare. So finally, I would like to touch another topic for biosecurity. So we also have developed the rapid on-site chemical and biological agent detection system. As you know, so unfortunately, sometimes rarely occur the chemical or biological terrorism. So in this situation, first responder want to know so this agent is which. So because of so if the agent is chemical agent like the VX gas, so people have to go far away, and so air have to diffuse immediately. But if the agent is a pathogen, so people have to isolate to prevent the spread of the infection. So it means the on-site management is completely opposite. So there is the requirement from the police and fireman as a first responder. So as a concept, the system have to discriminate chemical or biological agent immediately. So this system contains the different three types of biosensor chips in one system. So one is the electrochemical enzyme chip for nerve gas
誰で
detection.
もどこでも簡単にわずか
One is
15
the
分で定量
glucan-based
PCR が
LSPR
可能に
chip
なり
for
ます。
toxin and
この画期的なイノベーション、
chip
マイクロ
for
オーシャンの鍵は
spores.
円盤型のチップ、
This system have also so
DNA
air
が含ま
sampling
れる
unit
検体さえ準
function,
備すれ
and
ば、
so this
試
system
薬の
works
調
by
合
the
作業はす
battery.
べて検体採取キットとチップの中で自動で行
So
われ
this
ます。
research was done by collaboration with Dr. Seto. So he was former chief director in National Research Institute of Forest Science. So we designed the air sampling unit, and the agent can collect it into the unit from the air like this. So then the collected solution was divided to each sensor. So then the saline or VX gas in air was sucked and continuously could be detected at less than lethal levels. this detection method used the electrochemical response by the inhibition of the acetylcholine esterase reactions. So botulinus toxin also was possible by the specific glycan affinity and erythroid response. So I want to finish, and so sorry, I apologize that my talk was a little bit scattered. So now we are paying the effort for realization of our devices to the society. So I hope our device can help you somewhere in future. So thank you for your attention.
Thank you so much, Dr. Saito, for sharing your work with all of us. So now it's time for our question and answer session, our open forum. As I mentioned earlier, you can type your question in the chat box. Also, I was informed earlier that unfortunately, Dr. Navarro cannot join us this afternoon. So you can ask questions for Dr. Saito and Dr. Nunuswan. Please. While we're waiting for our audience to type their questions, let me ask a question first for Dr. Nunuswan. So, sir, you mentioned earlier that you conducted a study in 2020, if I'm not mistaken. Can you share with us which factor in your study correlated well with disease?
Okay. I'm not so sure. So my camera is working. Can you see me? But I think you can hear me, right?
I can hear you, sir. Tech, can you spotlight Dr. Nunuswan? Is that possible?
Yeah, I was asked to turn on the video, the camera, but it did not show. Anyway, okay, to answer your question, well, I am assuming that you were asking about some of the result that which of the topic of the biosecurity that I mean can protect from the virus. Is that the question?
Yes, sir.
Well, yeah. Unfortunately, I mean, it's not really clearly from our so far the result. Most of the lab result, it turned out to be negative. It means that our biosecurity measure were very successful, and we can basically, you know, protect or block the virus from entry. So, by the way, I think I can speak from my experience from our colleague. The most important part was the swine itself, and also the human. I mean, human from the outside that get into contact with some other the staff in the farm. These two important factors that biosecurity should emphasize. Okay, so basically it was about human and also the animal itself that could be a risk factors. Okay, thank you.
Thank you, sir. There's another question here in the chat box for you from Professor Pagoso of UP Manila. He's asking, sir, aside from swine, are there any other animal species which are at risk of getting the ASF virus? And the second question, is there any vector for the virus?
As the name implies, it was African swine fever. So for now, I mean, so far, this virus caused the disease particularly exclusively for pig, and pig is mean like not only the domestic pig, also the wild boar. wild boar that are roaming around in the forest, and lots of wild boar also in the European country and some in the Asia as well, probably in Russia or that kind of area. And to answer the second question, so far we cannot determine actually the vector. We can think of as a mechanical vector. I mean, basically the vector is mean that the virus can sort of replicate in the vector. However, we are talking about the SF, and the vector in this case is so-called mechanical vector. What does it mean? Mechanical vector that we are having experience or problem with is basically is the fly. Fly is an insect that can flying around from one farm to another farm, and it can, I mean, if it's leg or its body touching the formite that has been contaminated with virus, it can carry from one farm to another farm. And this is also a risk factor as well. So in the farm with a good biosecurity measure, they not only have to worry about they have to take care of the pest, especially this fly as a vector. I mean, particularly mechanical vector.
Thank you so much, Dr. Nuno-san, for your answers. My next question is for Dr. Saito. Dr. Saito, you mentioned in your talk that the results for IMP6 gene detection is or has 86% correlation with cultural methods. My question is, did you attempt to adjust your device to hopefully improve or increase the correlation?
Yes, so basically, so my device is based on the PCR. If so target has a DNA, so of course maybe we can detect any other target, pathogen or bacterium or anything is okay.
Okay, thank you so much, Dr. Saito. As a follow-up question, is there any device that you have developed that is already commercially available?
Sorry, not yet commercialized. So now, so we have been developing the device construction. Not yet finished, but our goal is to make the venture business. My near future, I'm paying the effort, but near future, I want to release the
in the very near
future.
Yeah. We're with you in that endeavor. Good luck. So there's another question here for Dr. Saito, again from Professor Pagoso of UP Manila. He's asking, what is the main difference between your device, the chip PCR, and conventional PCR? And once commercialized, is the cost cheaper or more expensive?
So actually, maybe not cheaper. So our device, conventional PCR method is already so many user. So, but our device merit had so more easy and rapid. Always so we have to set the little bit so higher cost.
Okay, thank you, sir. I'll just check the chat box for if there are other questions. Okay, there's none at the moment. So lastly, can you please leave a message? For example, probably you can share some information or results that you were not able to share with us in your talk. There's something that you would want to share with us. Dr. Nunuson, you can start.
Oh, okay. Thank you. Now I can see my face. Okay. Yeah. Okay. So my comment here is that depending on the result of the lab, that so far, as I mentioned earlier, that the result is pretty favorable because we did not see the positive result. So it means that the restocking probably has to rely on effective or sustainable biosecurity measures, and we use the lab validation in order to monitor and feedback to the farmer as soon as we can get the positive result. So these two things are working all together between the assessment and management. But the really foremost and significant was our meeting today is about biosecurity. So this might be a one size fit all that can be used. However, the biosecurity cost some expense. I mean, it's come. I mean, at the expense of the something. So we might want to finally, at the end of the project, that we can finally scope to the so-called minimum biosecurity measure, because we have a long list of the measures. So we will try to minimize or to find the minimum minimum biosecurity measure, so that the farmer will not this will not cause too much trouble in terms of expense or financial burden to the farmer. Okay, that's my comment.
Thank you, sir. I was just wondering, do you still have a big problem with ASF in Thailand right now?
Right now, actually depends on the size of the farm. For the so-called integrated farm, the big farm, the big player in the industry, they have no problem because they have they were prepared for this one for a long time ago. However, for the small size and medium size, they are fighting, but I think we might win this battle finally, and it's the situation is getting better. Because why I saying that? Because based on the result that most of them are negative is one thing, and the farmer got the they get some of the incentive because of the price of the pork is getting high, so they have sort of a the profit that waiting for them. So they're willing to renovate or to improve their biosecurity in order to finally they can have a sustainable way to make the profit from the high price of the pork.
Okay, thank you so much for sharing your experience with us, Dr. Nuno-san. Dr. Saito, your message, please.
Thank you for today. So, yes. So I want to say that again. So in future, so my device will maybe if I'm happy to in future, so I take to the world. So I'm paying the efforts now. お願いします。Thank you.
Thank you, sir. I was just informed that Dr. Navarro has joined us in this breakout room. Dr. Navarro.
Hi, good afternoon. Sorry,
Good
apologies. I
afternoon.
was in the other room. I'm so sorry, but happy to be
Oh, okay. Naligaw si ma'am. Anyway, Dr. Hani, I actually have a question for you now. I was wondering if your team has plans for expanding your capacity building endeavors or advocacies to educate teachers, high school teachers. Ano po yung the root of this particular question is this. I've been getting inquiries from high school teachers who serve as advisors to students for their capstone projects, and they ask me for pathogens like MRSA. So, what's your take on this?
Yes, ma'am, I hear you. That's totally a valid concern, and we also feel the same way po, ano, that we should educate the younger generation, start as early as high school students, because as you've said, they're already starting doing a lot of experiments, even involving biological agents. So right now, NTCBB also offers training to high school institutions. In fact, no, we have graduates of the Advanced Fire Risk Officers Training who are instructors of the high school institutions like the Philippine Science High School in Iloilo. So I think it's a good start. And I guess what would be great if the biosafety will be the concepts of biosafety will be included in the curriculum as early as the high school students, because there are risks, no, and we have to protect especially our high school students who are not fully aware of the risk associated in handling organisms.
Well, that's great, ma'am. I wish that I will never get the same inquiries again in the very near future. Anyway, I think we have time for only one question. And I'll just ask you, Dr. Navarro, if you can, leave a message to the audience, something that you were not able to share with us in your talk earlier.
I guess my message would be I guess it is to repeat what I've said siguro, no, is biosafety should start now. I mean, the awareness should start now. I mean, there has been a lot of efforts, but I think we need to start also in thinking about how we can integrate that into the policy, no, especially not just the institutional policy, but on a national level, how we can integrate those policies on a national level to have that kind of impact then in terms of reaching the high school students, like you've mentioned, the research institutions, the hospitals, the clinical setting. And what I'm going to offer, I believe is that NTCBB is definitely open for collaboration. So if there is interest for collaboration in promoting biosafety awareness in your institutions, we're very open to collaborate with you. And yeah, thank you.
Thank you so much, Dr. Navarro, and thank you to all our speakers. I think it's time to give them their certificates. Is that correct? There you go. Okay, so let me read the citation. Which is which? Are they the same? Anyway, so the joint SBJ meeting with Indonesia, Philippines, and Thailand, and the ASEAN plus Japan Consortium for Microbiology and Biotechnology gives this certificate of appreciation to Dr. Rohani C. Navarro for sharing her valuable knowledge as a resource speaker in the symposium joint SBJ meeting with Indonesia, Philippines, and Thailand in conjunction with the 74th annual meeting of the Society for Biotechnology, Japan, given this 21st day of October 2022 at Osaka University, Osaka, Japan. Signed, Fukusaki Eiichiro, President, the Society of for Biotechnology, Japan. Thank you so much, Dr. Navarro.
Thank you.
The same certificate is given to Dr. Supachai Nunusan, again for sharing his valuable knowledge as a resource speaker in this symposium. Thank you so much, Dr. Nunusan. Lastly, the same certificate goes to Dr. Masato Saito for sharing his valuable knowledge as a resource speaker in this symposium. Thank you so much to all three speakers. Okay, I think it's now time for a photo op. Is that correct? Okay. Who will lead the Kodakan to non-Filipino audience here? Filipinos love Kodakan photo op sessions. Here we go. Can you warn us so that we can smile accordingly? Say cheese. Okay, we're done. Thank you so much. So if I remember correctly, we'll have a very short health break. Okay. So thank you so much for your attention. Have a good afternoon.
All right, good afternoon, and welcome to the second part of our afternoon session on biosafety and biosecurity for today's joint SVJ meeting with Indonesia, Philippines, and Thailand. Let me introduce the next speaker for this round of talks. Our next speaker, Dr. Ir Sri Harjati Suhardi, is a faculty in the School of Bioscience, Department of Microbiology, Faculty of Natural Science of the University of Kent at Canterbury, UK in 1995. She became head of the Bioscience and Technology Research Center at the Bandung Institute of Technology from April 2021 to December 2022. Presently, she holds an academic and research position at the School of Life Sciences and Technology and Biosciences and Biotechnology Research Center, formerly Center of Life Sciences at the Bandung Institute of Technology. She has received numerous local and international awards and recognitions for her works in various areas of biotechnology. Ladies and gentlemen, let's all welcome Dr. Irshri Hajarti Suhardi.
Good afternoon,
Thank
ladies
you,
and
Mr.
gentlemen,
Chairman.
all the participants of joint SPG meeting. My name is Sri Haryati Suhardi from Bioscience and Biotechnology Research Center ITB, and I also in School of Life Science and Technology ITB. This afternoon, I will be presenting my paper on biosafety and biosecurity challenge during COVID-19 pandemic, case study ITB. As we all know, COVID-19, the coronavirus, and we also call SARS-CoV-2 virus, has caused the pandemic since the 2019. And we have the data by Worldometer that over 629 million cases with 6.5 million deaths worldwide. This data was taken on the October 14th, 2020. In Indonesia, in March 2020, Indonesian government established the condition which called a large-scale social restriction. And these regulations have the impact on ITB activities, all the activities, lecturing, laboratory work, and also the meeting. As a response to this situation, ITB established a COVID-19 task force, and the task force proposed this principle or this approach, which is a C. It's safety, ease, and awareness. Safety, to, to communicate to all the ITB staff what is the safety we need in this situation. And we also getting ready for new normal at that time, and then how this design will be accommodated by our uh, health and safety program. And also we have to define what's the changes we need to do to all the civitas academic of ITB. Ease. The basic principle of ease is we have a approach on genuine empathy, because we understand that it was not difficult for all the academic or student to start working at home. And we try to get to know what is the uniqueness of COVID-19, what is the impact. And at this time, we didn't know what we have to do and how long the pandemic will last. And ease means we have to open mind to listen to all the staff, to all the students, and we discuss with the aim to have a better and better approach. Awareness with the principle of let hear from us. So we have to be ready to give all the necessary information. And we also develop a guidelines for the academic civitas for for them who still want to work and who has to do and to finish their research. And also in the awareness, we have to understand our capacity and our limitation. Risk assessment is defined as a critical tool for evaluating this COVID-19 virus, which is a severe acute respiratory syndrome coronavirus 2. And we need to do this assessment because at that time we have very limited available information about this COVID-19 virus, and also how the disease they cause and how severe if the disease impact one of us. And ITB adopt a unique framework for this risk assessment. And one of them is ISO 35001 2019 on biorisk management for laboratories and other related organizations. And this document contained the procedure or guidelines how to identify, how to assess, controls, and monitors all risk associated with this COVID-19 virus or generally the hazardous biological materials. The biological analysis that we did, we tried to identify characterize the health, safety, and security risk. This is what basically we did. And then we follow how to implement, how to measure the effectiveness, and most importantly, how to communicating the control measures that we're going to apply to our society in ITB. The adaptation of this and risk analysis approaching to manage the biosafety and biosecurity ITB, and we also use the relevant regional, national policies, and also WHO procedures. The result of the biological risk management, it helps or it gives ITB a mechanism to protect their staff and students from intentional or unintentional release or exposure of COVID-19 to them. And also the risk analysis enable us to move towards a comprehensive biological risk management framework, and we use a science-based and specific to an individual faculty or laboratories circumstances, especially they are who have a special task on COVID-19 virus works regarding their presence or their studies on genome, for examples. Basically, we implement the biosafety and biorisk in ITB with adopting of a AAA principle, which are agile, adaptable, and aligned. Agile means we respond to short-term changes in demand based on COVID-19 information, and we plan to act quickly. We have to be able to handle external disruption smoothly, and also important, cost effectively. And in the end, we want to have a fast recovery. The second is adaptable. Adjust to adapting new habits. This is the program run by the government. The aim is to accommodate the demand for changes, generating from COVID-19. And also it's stated in the government regulation. Aligned. Aligned means that aligning the interests of all ITB civitas with the demand of regulations related to COVID-19. And we also learn that each civitas, through study program, faculty, schools, they maximizes their plans, which in turn how the ITP performance will also be optimized. What is the method we use to achieve the agile condition? Firstly, we promote flow of information with staff, student, and ITP leaders. ITB established ITB Amari Task Force. The main task of this task force is to support the strategy of ITB management of COVID-19. And secondly, develop collaboration with all local, national institutions related to COVID-19 management. And we also have collaboration with national and regional health department. And thirdly, draw up contingency plans and develop crisis management teams. Our rectors pro propose an ITB COVID-19 task force. There are 8 members, 8 of the task force, and the chairman is Dr. Ernawati. She is the virologist, and others are with varied background to support this task force, and also implementation team of adapting to new habits in the level of faculty. The triple A, the second is adaptable, and the method we use are monitoring the evolving information of COVID-19 from local, national, and global sources. And these sources we use to update the necessary regulation. And then evaluate the needs of ultimate community and not just immediate communities. This is important because we want to achieve all the KPA of ITB, the department, and also the faculty. And thirdly, create flexible plan and program, particularly for lectures, laboratory works, for students in their final years, for lecturers and researchers which have special tasks, especially on COVID-19 research, important meetings, and also building management, not to forget. And in adaptable phase, we determine which unit can play roles in detecting and monitoring the spread of COVID-19 amongst our staff and students, and then followed by tracking and tracing. To what extent the effectiveness of our program to prevent, to reduce the rate of spreading in our community. And thirdly, managing positive cases at staff and students. As we all know, at that time, it was not easy to find the place for personal isolation, for personal quarantine. And ITP, with the help from infrastructure unit, health service, and collaboration with other party partner of ITP, we have isolation rooms available for our staff and students. And thirdly, aligned, how we aligned our ourselves, yeah, our program, our staff. And firstly, the method we use is exchange information and knowledge freely with all ITP stakeholders and our partners. And then we lay down roles, tasks, and responsibilities clearly for staff, academic students and visitors. We have letters from our Secretary Institute, and is updated weekly. So we all knows what we have to do, what we supposed to do, and without forgetting our task and responsibility. And thirdly is equitably shares risk, costs, and gains of improvement initiatives. And this is important. With this approach, we know that we can help each other, and anybody, no one left behind. And to align our program, we established health monitoring system. It's managed by Office of Secretaries Institute. We call ITB COVID Track, and here's the link. And this is how students, staff, and also our visitors fill in once we are entering the university. And also this is for anybody who has symptoms or have positive cases. The biosecurity system, and the biosecurity is a discipline. Yeah, we focus on the security of microbiological agent and toxic. This is in general what biosecurity definition. And this is addressed for threatening human, animals, environment, and economic, as stated in the CDC document 2009. And we concern about biosecurity with the aim to prevent our staff with bad intention from reaching our virus. And we also try to avoid the transmission of hazardous and also other valuable biological materials. And how the ITB approach on biosecurity precaution. And basically, this is the document from CDC and WHO. So we adopt this approach. Firstly, the physical security with the aim to minimize the risk of access to the containment without authorization. And secondly, personnel security. Basically, it's a measure focusing on the insider threat. And thirdly, material controls. So we establish the environment for the insider who intend to steal or use the agent for other reason than the research or other harmful reason that might come up. And transport security. This is the mechanism to reduce the theft risk from insider or outsider theft. And as we all know, that we receive materials contain virus from our party, and we also have responsibility to analyze the sample from our local government and also from central government. And lastly is the information security. Yeah, we use some policies and practice, yeah, to protect the critical knowledge. This is the new lab that we established with the funding from Jawa Barat government, the ITB BSL2 laboratory. Yeah, to support our biosafety and biosecurity system, this lab was installed with a building automation system. And we can see here that it's controlled automatically, and on the right we can see the access only given to the person that's been listed to enter this laboratory. This is just one example how the biosecurity in ITB improved and increased, especially during the pandemic of COVID-19. To summarize, the ITB COVID-19 Biosafety Plan and implementation with the condition as the constant and complete implementation of all the necessary duties without showing tolerance. We really emphasize of no tolerance. And this condition is enhanced by the involvement of all stakeholders from top leaders, our rectors, and the vice rectors to the frontline staff. And secondly, by strictly following standard operating procedures, regulations, and timely communication of risks and pitfalls, resulting high quality outcomes. And the condition we have low number of death case, manageable positive case, no accident or incident of contamination. And thirdly, adopting a systematic framework to identify and manage risk posed by these emerging pathogens COVID-19 result in increase in FTB safety and higher quality processes. The closing remarks. And we believe that with the SEA strategy, dedicated preparation and implementation, we can learn to sail these stormy seas and get our activity as ready as possible to welcome back our ITB Civitas Academic. Thank you very much. Good afternoon.
Thank you very much, Dr. Suhardi, for the very informative talk. For our audience, please type in your questions for our speakers here in our chat box, and we will have the open forum after the talk of the third speaker. Our next speaker is Dr. Sugiono Supatra, and he earned his PhD in veterinary science from the University of Adelaide, Australia in 2018. He is currently a researcher for applied zoology at the National Research and Innovation Agency, Indonesia. Let's all listen to his talk titled Tent, Wildlife Trade and Potential Zoonotic Transmission. Dr. Supatra, the virtual floor is now yours.
Hello everyone, good afternoon. My name is Sugiono Saputra. I'm a researcher at the Research Center for Applied Zoology, National Research and Innovation Agency. And first of all, I'd like to thank to the committee who invited me at the joint SBN meeting with Indonesia, Philippines, and Thailand to deliver our current project related to wildlife trade and their potential zoonotic transmission in Indonesia. Wildlife trade refers to the trade of products that are derived from non-domesticated animals or plants that are usually extracted or harvested from their natural environment or raised under controlled conditions. It can involve the trade of living or dead individuals, tissues such as skins, bones, or meat, or other products. The legal wildlife trade is regulated by the United Nations Convention on International Trade in Endangered Species of Wild Fauna and Flora, or CITES, which currently has more than 180 member countries called parties, including Indonesia. Wildlife trade is a serious conservation problem, has a negative effect on the viability of many wildlife populations, and has been linked to the emergence and spread of new infectious diseases in humans, including emergent viruses. And according to the new data from CITES, Indonesia sits at number 9 on a list of the 80 countries with the highest number of wildlife specimens legally exported overseas. Due to the growing consumer demand for animal products in the form of clothing, food, accessories, or as a pets, the wildlife trade is fast and profitable. And it has been wide scale since 1990s. However, it reached the peak at 2018 and then significantly decreased in 2020 due to the pandemic situations. And this picture shows illustrate how many wildlife trades are taking place worldwide since 1975. And on the right side is the most exported live animals in the last 46 years, which is dominated by reptiles, fish, and also birds. Among mammals, which is very well known for the reservoir of many potential pathogens, primates was the most traded order, with the genus Macaca forming the most of the global trade, followed by other carnivores. This figure shows illustrate the magnitude of flow of the global live mammal trade, which is mapped according to the class, order, family, genus, and exporter and importer countries code, according to the CITES database between 2012 and 2016. The thickness of the colored bands in the figure reflects the number of animals traded and the magnitude of trade between the countries. This is just to remind us that wildlife trade is actually only one of many drivers of zoonotic diseases. And this is an overview of how certain factors lead to the disease emergence and reemergence is outlined. Also illustrate how these various developments interact to promote the emergence of new diseases and the reemergence and persistence of existing ones. There are three main domains, including humans, animals, and also environment. And between these three domains, there are several interfaces from human, animal, and environment interfaces, which all contribute to the drivers of zoonotic diseases. Well, in my talks today, I'd like to emphasize these interfaces between human, animal, and environment in Indonesian context, which may include several activities or several places which can be regarded as hotspot of zoonotic disease transmission from Indonesian wildlife to human populations. These include wildlife hunting and poaching, and then several places such as wildlife slaughterhouses, which is quite popular in Indonesia, and then also wet markets that sold wildlife meat or bush meat, and birds market, which are sold any animals for pets. I'd like to give an example of these activities, wildlife hunting and poaching, which is very well practiced and very well organized in Sulawesi Island. And actually, the wildlife hunting and trade extend to all provinces in Sulawesi, as most of the animals sold in North Sulawesi were not locally sourced. And the overview of the wildlife trade networks in Sulawesi and its key factors for the taxa most commonly traded include bats, rats, wild pigs, snakes, and other exotic animals. They usually are well organized and easy to access network involving many actors, including the hunters, local dealers, the middlemen, and also several supermarkets, restaurants, and markets who like to sell this bush meat from which is hunted from the nature. The activities may include passive hunting and also active hunting using traditional method, which may that the hunters itself have a minimum requirement for biosafety during the hunting. And for large-scale hunting, usually the hunters and also the local dealers, they provide aspect to and also to freeze the bush meat immediately before they sell to the market or supermarkets in North Sulawesi. Well, wildlife meat routinely available for sale in more than 70% of the market surveys in North Sulawesi, according to the latest data from Latina et al. And the most commonly found in this market were flying foxes, wild pigs, rats, and also snakes. Wildlife meat usually prepared from frozen stock. The traders usually obtain this for stock from the hunters or local dealers or the middlemen, and then sold to the consumers after roasting, as you can see this in this picture. And several wet markets in North Sulawesi, they have a when they have a more demand, consumption increase during the Christmas holiday and before the pengucapan or the Minasan Thanksgiving. And in this wet markets in Sulawesi, we have a monitoring on the potential zoonotic disease, which is conducted at least 4 times a year with a collaborative project with Australian Center of Disease and Preparedness, CSIRO. Another place which is very that we need to pay attention in regards to the aspect of biosecurity include also wildlife slaughterhouses, which is commonly found in several places in Java Island. The wildlife in these slaughterhouses mainly include reptiles and amphibians, and this all include many species of snakes, frogs, and also geckos, which is sold as meats, medicine, and fashion products. And these are actually one of the export commodity from Indonesia to overseas. However, these activities are located in densely populated area with poor sanitation and waste handling. And we have been monitored these places as well in our program. And according to our latest data, that these places have highly risk of environmental contamination, especially salmonella, which is commonly found in many reptiles and amphibian species. Birds markets is also quite popular in Indonesia, and I think in each city in Java Island, most likely they have birds or animal markets that sell many or various bird species. And although the name is bird market, they also say sell other taxa other than birds, including small mammals, also reptiles and amphibians, and usually they are traded as a live animals. In several areas, wild animals can be found as well for medicinal food, including bats, and multiple leaf species commonly found in one stall, which is highly risk of disease transmission. And due to the unhygienic sanitation standards and the connection of the spread of zoonosis and pandemics, and critics have grouped live animals markets together, especially in Asia, Africa, and in general all over the world are prone to health risk. We also include this bird market as a targeting for potential zoonotic disease surveillance. We're targeting several viral pathogens in several classes of animals. Well, it is important to know that this disease, the wildlife trade, is also followed by the disease trade, and this figure illustrates the mean potential zoonotic disease trade for 4 periods of time. And the trade landscape has shifted over the past 4 decades. Between 1980 and 1989, the Philippines and Indonesia accounted for the majority of export. But since then, the little has shifted to the US and Germany. But the smallest but still substantial portion of the export coming from China and other Asian countries. And between 1990 and 2010, the US and Canada accounted for the majority of all trade flows, including both import and export. And the continents are indicated by this picture. The continents are indicated by different color groups. For example, North America, purple, Europe, Asia, Africa, and other areas. And this figure depicts the trade of development of primates, all just and macacas, especially, which are the major species among primates. And the number of export flows are shown in the left panel, and the size of the zoonotic disease trade is shown in the right panel of the same figure. And since the mid of 90s, the volume potential zoonotic disease traded in macacas has increased substantially from increasing demand in the fields of biomedical and biowarfare research. And to address this issue in regards to many activities and also places which is considered as the hotspot of zoonotic disease transmission, a conceptual framework that can guide interdisciplinary research on zoonotic risk. The first step, it requires the characterization of risk environment, including an understanding of ecological and biological risk drivers. And the second is entails the production of plausible risk scenario that explore the ways in which risk environments may influence pathogen emergence, evolution, and transmission to human population. And the third is analysis that evaluates the health and economic burden of a given risk scenario in order to identify policy option of risk management and in collaboration with stakeholders and agricultural experts. Then what we can do to help to address, to minimize the risk of zoonotic transmission. So in this ongoing project, we have AED or PZD surveillance or emerging infectious diseases and potential zoonotic disease surveillance, uh, which surveillance at the higher risk interfaces such as mixed-lived animals and wildlife markets, wildlife animal trade and transport chains, and peri-urban interfaces where domestic animals, wildlife, and human interacts. We have two main places, including the main island in Sulawesi and also in Java. And to conclude, whenever wild animals and people are crowded together, many experts say that there is a risk to public health. Therefore, it requires minimize human interfaces with wild animals and wild species Although it's a huge effort, but then it's very crucial for human public health. And then other things is to eliminate a transmission point where the likelihood of viral spillover to humans is high, such as unhygienic commercial markets. And then monitoring or surveillance of potential zoonotic disease is an urgent need to contribute data towards evidence base for biosecurity policies and regional pandemic preparedness programs. And also the last, of course, decision making of wildlife management and involving the highest level of governments and locals on a permanent basis. And that's all from me. Thank you.
All right. Thank you very much, Dr. Supatra, for that very interesting talk. Again, for our audience, please type in your questions for our speakers in the chat here in our official chat box, and we will have the open forum after the talk of the last speaker. Speaking of our last speaker, but I think definitely is not the least, our last speaker is Dr. Ruichi Hirota, an associate professor at the Graduate School of Integrated Sciences for Life at Hiroshima University in Higashi, Hiroshima, Japan. He received his Bachelor in Engineering from Hiroshima University in 1997 and his PhD from Hiroshima University in 2002 under the supervision of Professor Hisawa Otake, where he worked with molecular analysis of chemolithoautotrophic ammonia oxidizing bacteria for nitrogen removal from wastewater. He was appointed as assistant professor at Hiroshima University in 2007 and began working on the phosphate metabolism of bacteria for sustainable phosphorus resource management under the supervision of Professor Aiko Kuroda. He was promoted to associate professor in 2017 at the Graduate School of Advanced Sciences of Matter at Hiroshima University. He was a visiting scholar at Carl Woos Institute for Genomic Biology at the University of Illinois at Urbana-Champaign, where he worked on the reduced phosphorus compound metabolism in bacteria, and he has been a project leader of Advanced Low Carbon Technology Research and Development Program at the Japan Science and Technology Agency since 2016. Ladies and gentlemen, let's all welcome Associate Professor Hirota.
Good evening, everyone. I'm Ryuichi Hirota, Hiroshima University, Japan. At first, I'd like to appreciate Professor Honda and the organization committee to give me an opportunity to introduce my research. Today's title of this presentation is Synthetic Phosphide Dependency, a biosafety measure for the use of genetically modified bacteria in open environment. Synthetic biology is an emerging technology and offers innovative approaches for creating highly engineered bacteria by recent cutting-edge technologies such as metabolic engineering, DNA synthesis, and genome editing and next-generation sequencing. Synthetic biology offers great promise for addressing global requirements to solve medical and agricultural, environment, and energy problems. For example, engineered bacteria that kills tumor bacteria shows high nitrogen fixation activity for biopesticide, degrading pollutant bacteria, and microalgae that produce fuel oils or chemicals with high productivity. They are already developed and are waiting for practical applications. However, currently, these applications are difficult to realize because there is a concern that the use of genetically engineered strains at open environment is considered to affect biodiversity. Currently, in most countries in the world, the use of genetically modified bacteria is regulated by the Cartagena Protocol. The Cartagena Protocol is the agreement of parties to regulate the cross-border activities of genetically modified organisms from one country to others. Most countries, including Indonesia, and the Philippines, and Thailand, and Japan, ratified the Cartagena Protocol. In Japan, under this protocol, the use of genetically modified organisms is divided in two types. Type 1 is for an open environment, and type 2 is for the use in the closed environment. In the case of microorganisms, almost all cases are used under type 2 regulation, and none of the type 1 use has never been applied at commercial scale because there has been no biosafety measure to prevent the risk of engineered bacteria on biodiversity. A possible way to prevent the uncontrolled proliferation of genetically modified organisms, GMMs, is to use biocontainment. Biocontainment is a biosafety measure that limits the growth and survival of GMMs only in a specific or limited condition. One of the major strategies for biocontainment is to creating synthetic nutrient requirement. Like this drawing, if an essential gene for synthesizing an essential nutrient is deleted, the contained microbes can only grow in the culture facility where the required nutrient is supplemented and cannot survive or grow outside of the facility. The point of this strategy is that the required chemical should not be available in the environment. By the way, we have been studied and researched phosphorus metabolism of bacteria. Phosphorus is an essential nutrient for every organism. We have been analyzed the phosphorus metabolic pathway of bacteria and apply the ability for sustainable phosphorus resource management. For example, we created polyphosphate accumulating bacteria, which can takes up phosphate from wastewater and recover the phosphorus resource as a polyphosphate. In addition to phosphate metabolism of bacteria, we recently focused on phosphite, a reduced phosphorus compound whose oxidation number is +3. The important characteristics of phosphite is that it is an extremely rare compound and almost not present in the environment. And a limited number of bacteria can metabolize phosphite. We have found a bacterium that oxidizes phosphite from soil. This bacteria has the enzyme named phosphite dehydrogenase (PTXD), responsible for phosphite oxidation, depending on the reduction of NAD. One interesting application of phosphite dehydrogenase is that it offers selective cultivation of microorganisms without using antibiotics. If you introduce PTXD gene to host organisms, they can grow on phosphite, and no other contaminant can grow in a medium containing phosphite as phosphorus source. This methodology allows you to perform cost-effective and safer cultivation of microorganisms, especially suitable for industrial-scale cultivations. Now, talking back to biosafety, other than yeast and E. coli, we could successfully confer the ability to grow on host site to microalgae and even plant. By the way, please remind the characteristics of host site and phosphate. Phosphate is not present in the environment, and the available phosphorus source in the environment is phosphate. So if these PTXD introduced organisms lose the ability to use phosphate, they will no longer grow or survive in the environment. But to achieve the phosphate dependency, there are three requirements. First, we need to confer phosphate oxidation activity to host bacteria. But this can be achieved by the expression of PTXD, as I mentioned before. Second, we need to disrupt endogenous phosphate transporter. But this can be achieved by the conventional gene knockout system. Third, which is most important, is to introduce phosphate-specific transporter that not take up phosphate. However, such transporter have never been reported, so we characterized a variety of transporters originating from various bacteria, including E. coli and soil bacterium and cyanobacteria. Basically, most of the transporters that can take up both phosphate or phosphate, or only phosphate. However, fortunately, we could find a transporter that takes up only phosphate, but not phosphate, from soil bacterium Pseudomonas stutzi. The name of the transporter was HTX-BCDE. By applying this transporter, we could create E. coli strain that is strictly dependent on phosphate. These photographs show that the growth of engineered biocontained strain only grow on phosphate, but not on phosphate-containing medium, various phosphate-based medium. In addition to this phosphate dependency, this strain showed this strain lose the ability to grow on lose the viability without containing phosphate. So this characteristics is beneficial to increase biocontainment efficiency. This strategy can also be applied to other bacteria. This is the example of the cyanobacteria Synechococcus elongatus. You can see this strain can grow only on phosphate, but not grow on other phosphate-based compound. In order to quantitate the containment efficiency, we perform to measure the escape frequency. Escape frequency is determined by counting number of mutants that grow on non-permissive growth condition, that is phosphate-containing medium. But when we measure this frequency on phosphate-containing media, we didn't detect any mutant. That means really high containment efficiency. By quantitating the detection limit, we found that our methodology showed the most highest efficiency compared to ever reported strategies. But we recently found that escape mutant can arise in a specific condition that the medium containing both high concentration of phosphate and phosphite. The frequency is about 10 to the minus 10, which is still high containment efficiency. But it is desirable to suppress the emergence of this kind of escape mutant. What we did at first was to identify the mutation site and found that it was very interesting, and we found that the mutation is always found at the 2010th amino acid phenylalanine of HTXC, transmembrane unit of HTXBCDE. So, based on this finding, we replaced this amino acid with other amino acid that require more than 2 mutations to change the amino acid that allows phosphate uptake. And we could successfully suppress the emergence of the escape mutant in this condition. This result suggests that one amino acid alteration is possible to alter the substrate specificity of phosphate transporter. So we further tried to apply this strategy to eukaryotic cells. A typical eukaryotic phosphorus transporter is a proton and phosphate symporter, and can be also take up phosphate. Previous structural analysis reported a highly conserved 5 amino acid present in the fungal transporter. These residues are well conserved in other phosphate transporter of eukaryotic strain, such as yeast 484. So we targeted these amino acids to create phosphate-specific mutant transporter that can function in eukaryotic cell. By applying random mutagenesis, we could successfully create a mutant that can only take up phosphate and this strain showed the strict dependency on phosphate. Currently, we are applying this strategy to several other microalgae strains, which is expected for sustainable chemical production from CO2. We hope this biosafety strategy can help to promote the practical use of engineered strains that can contribute to sustainable material production. These are the pictures for the pilot scale culture of microalgae for the risk assessment experiment. We are currently performing biodiversity risk assessment using this facility with a collaboration with Professor Kashino and the National Institute of Technology and Evaluation. This work was done by collaboration work with the collaborator listed here. That's all for my presentation. Thank you for your attention.
All right. So we are done with all three speakers. Thank you so much, Associate Professor Dr. Hirota, for the very timely and relevant talk. At this point, we are now entertaining questions from our audience. May we request our speakers, Dr. Sohardi, Dr. Sohardi and Supatra, and Associate Professor Hirota, to please open your cameras and microphone for the question and answer. All right. I think we have a question for Dr. Sohardi. Is Dr. Sohardi here with us still? All right. Okay. Let's move on to, I think Dr. Sohardi got disconnected. So let's have the question for Dr. Supatra. Sir, to prevent one question from the audience. Sir, to prevent wildlife trade, can you give us any idea of the penalties or repercussions if ever an individual is caught doing wildlife trade in your country, Indonesia? Like what should be the punishment or penalty or jail time? So that's a question, sir.
Yep. Well, thank you for the questions. Well, actually, for the legal wildlife trade is regulated by CITES, as I mentioned before. But then for the illegal trade, that's maybe that's the thing that the that you mean that we should give a penalty if someone have illegally trade animal or wildlife which is harvested from the nature. Yes, I think there are some regulation as well in this penalty during when the illegal wildlife trade is happened. And I think in most cases from the policemen and then also from the regulator, for example, from Ministry of Environment and Forestry, they also have a regulation on these issues. But then most of the animal trade, wildlife trade that I presented here is mainly legal according to the scientists. So commonly practices and in the society in several areas of Indonesia, for example, in Sulawesi Island and also in Java Island, for example, in particular for the bird market in Indonesia. I think that's all.
All right. Okay. Thank you, Dr. Supatra, for your answer. I think we already have here with us Dr. Sohardi. Dr. Sohardi, are you ready to entertain some questions for you? Uh, Dr. Sohardi, I think you are muted right now. So Tech, can you please allow Dr. Sohardi to open her microphone, please?
Yes, sorry, it's okay now.
Okay, yes, I can hear you better now. Okay, Dr. Sohardi, a question for you goes like this. In terms of the minimum health requirements for COVID-19 in Indonesia, are schools in Indonesia back to the normal mode of teaching, like the traditional in-person class sessions? If yes, what are the practices done by the faculty and school management to prevent the spread of COVID-19 in your local schools?
Okay, thank you so much. So firstly, there is a government regulation for entering a building, and we call it Peduli Lindungi. It's an application. So this application should be installed in everybody's mobile, and each building has their QR. So basically, this
Okay.
application is to make sure that the number of people in the institution is following the capacity that's allowed. For example, some buildings 50%, some buildings up to 100%. And
Okay.
secondly, we are back to the lecturing, for example, and meeting. So for a session that's more than 2 hours, we require 50% capacity. But if it's less than 2 hours, it's 75 to 100% is allowed. But we still have to put on mask in the room.
All right.
It's compulsory, and we also state that it should be medical mask. So scuba mask or any fashion mask is allowed, but inside should be medical mask. And
Okay.
so that's a minimum requirement, because in some parts it's not possible for us to do distancing. Because if we, for example, in the laboratory, it's very difficult distancing. So one approach is mask and duration. So we limit the duration up to 2 hours. More than 2 hours, we have to break, and we let the air and the circulation do for 15 minutes, if possible.
I think Dr. Suhardi got disconnected again. Okay, maybe we can go back to the questions for her later. Okay, Another question, I think this one goes to or for Dr. Hirota. Associate Professor, moving forward, please give us one practical application of your study in our society today after the COVID-19 pandemic. So that's a question for you, sir.
Oh, that's a question for me.
Yes, yes, Dr. Hirata. The question goes like, for our moving forward, can you please, or the audience would like us or would like you to give a very practical application of your study in the society after the COVID-19 pandemic?
Yeah, actually, our target is the application of microorganisms for the for creating useful materials by cost-effective or cheap compounds. So the most impressive application will be the microalgae that can produce useful compound by photosynthetic and then converting carbon dioxide to useful materials. But currently, the production level is quite low if we use the wild type strains. So most of the researchers consider to increase the productivity or to add new ability to produce useful compound by introducing additional gene from different organisms. But they are genetically modified, so it would be difficult to apply. So that's why our biocontainment system can be contribute to realize such practical application. Yeah, so my answer is the microalgae is the most popular and then considered to are waiting to be applied.
Okay. All right. Thank you, Associate Professor Hirata. Much as we would like to entertain any other questions, in the interest of time, I think we cannot have them at this point. So let us now award the certificate of appreciation to our speakers for today. So the citation reads, joint SBJ meeting with Indonesia, Philippines, and Thailand, ASEAN and Japan Consortium for Microbiology and Biotechnology. Certificate of appreciation is presented to Dr. Sri Hajarti Suhardi for sharing her valuable knowledge as a research speaker in the symposium joint SBJ meeting with Indonesia, Philippines, and Thailand, in conjunction with the 74th annual meeting of the Society for Biotechnology Japan, given this 21st day of October 2002 at Osaka University, Osaka, Japan. Dr. Saputra. Also, the same certificate and same citation is awarded to Dr. Sugiono Saputra for sharing his valuable knowledge as research speaker also in this symposium. And lastly, we also would like to award this certificate of appreciation to Dr. Ruichi Hirota for sharing his valuable knowledge as also one of the resource speakers in our event for today. Thank you, doctors. And at this point, let's have the photo opportunity session with our speakers. So let's have the photo ops for the speakers first, and later, after, we will have the photo ops for all the audience that we have here right now. Speakers, can we request you to open your camera. Also, my partner, Assistant Professor Carlos. Let's have a photo op. Tech, can you give us the cue? Okay. Okay, thank you so much. May we also invite Dr. Saito, Dr. Noan Noel Swan, and Dr. Navarro, if they are still here. Can you please open your camera? They are the speakers in the first part of our session for today. Ma'am Millet, please join us with a photo op. Tech team, we are joined by Dr. Noan Swan. Another photo op, please. And for our last photo op, may we request the audience if you are okay with opening your cameras, kindly open your camera for us to have our photo op. I can see some cameras from the audience. We have Dr. De Leon here from the Philippines. All right, I think that's it. So tech team, can we have the one last photo op for today's session? Okay, thank you everyone for your participation in our photo op session. And I guess that ends our parallel session for today. Thank you very much for attending the joint SBJ meeting with Indonesia, Philippines, and Thailand, hosted by the International Center for Biotechnology, Osaka University, in cooperation with Consortium Biotechnology Indonesia, Perhip Human Biotechnology Indonesia, Thai Society for Biotechnology, and our very own Philippine Society for Microbiology, Inc. See you again next SBJ event, hopefully in a face-to-face meeting very soon. Kindly accomplish the evaluation form found on the SBJ TUA event page in exchange for your certificate of attendance. Once again, thank you very much and have a wonderful evening, everyone. At this point, may we request everyone to go back to the main plenary hall for some remarks and announcement. Thank you and goodbye.
Thank you. Bye-bye, everyone.
Bye. Thank you.
Let's all go back to the main plenary hall. See you there.
Bye.
Recording stopped. Recording in progress.
So thank you very much for the distinguished guests and the honorable speakers and the moderators and the participants and friends and students. And I'm very happy to finish this joint symposium. And I hope you could make good friends through presentation and the Q&A time. So I would like to invite for the closing ceremony, President of Society for Biotechnology